Hello guys, welcome to my YouTube channel. For this video, I'm gonna show you how to use Python to do a full and complete numerical simulation to solve a group of differential equations. For my previous videos, I primarily use Fortran to do this kind of a computation. But probably some people say, hey, why don't you just show how to use Python to do it? Because they may think the Fortran is kind of a little bit outdated. In my opinion, I never think Fortran is outdated because Fortran still has its specific advantage about doing the mathematical modeling. But I also agree that yes, Fortran has some limitations. For example, the way how the Fortran read and import the data, how the Fortran export data, and I'm not really sure about the most recent version of Fortran, but for the Fortran 90, looks like it doesn't have the function to plot the data after you finish the simulation. So yes, so here I want to show the Python because Python do have the advantage of importing the data, reading the data, and Python can also plot the simulation results immediately after you finish the simulation. Okay, so in this video, I'm going to show you how to do this. And still, I use this example. This one is called the first order sequential chemical reaction. I don't want to make it really complicated. The reaction is like x1 transforms into x2 and x2 transform into x3. This k1 and k2, they are called reaction rate constant. And here is the group of differential equations to represent this sequential chemical reaction. And I want to calculate and get the concentration of x1, x2, and x3 at the same time. And in the reality, this k1 and the k2, they are always time series data. They will never be the same, during 20, 30 days. If say the k1 and the k2, they are a constant during the whole simulation, so there is no reason to use the numerical method because you can just use the ODE solver in the Python, R, or MATLAB. Okay, so in this, and here is the K1 and the K2 used in this example. You can see K1 and K2, they changed all the time during the whole simulation period, and which is a 60 days. Okay, so let me walk you through the code. For the first one, I'm gonna read this CSV file and import the data. So the method I use is the pandas. So this is kind of really popular one in the Python world, and there's so many videos can walk you through. But anyway, after I read the data, I create another dynamic array, and I want to use this array to read this data again, and I will pass this K1 and the K2 to the main file. Okay, and because this group of differential equations has three specific differential equations, so here I define the dimension of differential equations, and here is the initial conditions for the time and time integration steps. Okay, and here is the initial conditions for the three chemical concentrations. The x0 is the initial conditions, which I said is a 50, 0, and 0. For here, the xi. Here, I want to say the xi is the array will be the simulation result of the concentration of the three chemicals at each time step. But I want to emphasize that this xi will be updated for each time step. So it is always updated. Be careful. And because this xi is always updated for every round of simulation, so I create another empty dynamic array at the beginning. And this two dynamic array will store the simulation result for during the whole time step. Just be careful about this because this one is updated every time. So I need one to store I need another dynamic array to store all the simulated, the xi, the concentration of these three chemicals. Okay. And here is the way how I import the time series data from this file. And here is a loop to do the numerical simulation. Because I kind of show you, because I show you the method like RK4, and this one I use the Euler method. And everything is kind of the same. Just be careful after you finish each simulation step, you need to adjust the TI and XI. And here is that I use this loop to store all the TI, the time step data, and this X out is to simulate, sorry, this X out is to store all the numerical simulation result for every time step. Okay, and after each, for example, when you finish this round of simulation, you need to adjust the initial condition again. And here is the way how I plot the simulation result. So here, and this is the Euler method, very famous Euler method. So I believe there's so many videos about this, and so I'm gonna skip this one. And here is here is another file where I define all the differential equations. Here could be really long, could be 20, 30 differential equations. But as I demonstrated in my previous video, I like to separate those files because by doing this, it is really easy to have your codes organized. And whenever there is a problem, it is really easy to debug. And just for example, this file is only for the Euler method, numerical simulation method. And this file is only for the differential equation. They can be easily organized, and it wouldn't just like you put all the codes together. It gonna look really clumsy, really chaos, something like that. Yeah. So I've tried this several times, and it should be right. So let me just do the simulation again. Okay. Well, basically this simulation is right, but there are some lines. But anyway, I believe this code is right. Just there's maybe a little bit bug, but I will debug it and I will post this on the GitHub. So you see this is X1. This is a typical X2 concentration in a sequential chemical reaction. This is a chemical 3 because X1 and X2 are all transform into X3. I believe the codes are basically okay. Probably a little bit, somewhere has a little bit bug, but I will debug it and I will post this on my GitHub page. Yeah, this is about the fortune, and hope this can help you a little bit. And yeah, that's it. And hope you have a nice day.